Hi class, we're moving on with chapter 4. We've talked about water and its important unique properties, why it exhibits those, and what are some of those unique properties that are important for understanding weather processes. And then we moved water up into the atmosphere. We talked about how we measure moisture in the atmosphere as humidity. We can measure it as absolute humidity, vapor pressure, mixing ratio, relative humidity, dew point temperature. And all of those measures are talking about the quantity of water vapor in the atmosphere. So now what we're going to do is talk about lifting an air mass and how do we lift air masses in the atmosphere and what happens to them when we lift them. There are 4 basic mechanisms or processes that lift air. The first is what we call orographic lifting, and that is physically just pushing an air mass because it collides with an obstacle, like a mountain range, right? So we've got air masses moving from west to east across the United States. Those air masses hit the Rocky Mountains and poof, the Rocky Mountains push the air masses up, and that causes lifting. Another process that can cause air to rise is when you have cold air colliding with warm air. And what happens then is that the cold air is more dense, the warm air is less dense, and the warm air gets pushed up over the cold air. And that's what we call frontal wedging. Another method that causes air to rise is what we call convergence, and that's when you have air masses converging and they have to go up. And then the last is a very important one for formation of thunderstorms, is what we call convective lifting, and that's when the Earth's surface is hot. By conduction, it heats the air that's adjacent to the Earth's surface. That hot air is less dense, and so it rises, and that's what we call convective lifting. So these are 4 processes that lift air in the atmosphere. And now what we need to understand is what happens when that air lifts. Now, we talked about how air pressure changes with elevation, with altitude. As we move up in elevation, air pressure decreases. So that means as air moves up in elevation, it's going to expand, right? Now, what happens to temperature of air when it expands? How many of you have ever let air out of a bike tire or used an air compressor? You squeeze it and the air expands as it comes out. What's the temperature of that nozzle or of the valve stem on your bike tire as you let the air out and that air expands? It gets really cold, right? So what we typically see is that as air expands, it cools. So as those air masses are rising and expanding, they are cooling. Now, in that process, there is no heat energy exchange. We've talked a lot about how if we add heat energy to something, the temperature goes up, or if we take heat energy away from something, then the temperature goes down. But this temperature change as air masses rise due to decreased air pressure has no exchange of heat energy occurring. So this is what we call adiabatic cooling. And so that means the air mass is cooling just because of the decrease in air pressure, because the air mass expands. So as this air mass rises and cools, what happens to that air mass's relationship with its saturation vapor pressure? Do you remember the graph that we looked at that related temperature with saturation mixing ratio? As temperature declines, saturation mixing ratio goes down. So as we move an air mass up, it's going to cool. And as it cools, its saturation point decreases. And so basically what we're doing is moving that air mass closer to saturation as we raise it. So as the air mass goes up, it approaches saturation, and eventually it gets to the point where condensation can occur. And that's the point at which it reaches saturation, it reaches the dew point temperature, and we can have condensation occurring. So a couple of important concepts here. There are 4 different mechanisms that cause air masses to rise: orographic uplift, frontal wedging, convergence, and convective lifting. And as air masses rise, they cool adiabatically because air pressure decreases. And as they cool, they're moved closer to their saturation point, and so eventually they hit the condensation level at which condensation can begin because the air mass has reached saturation.